Okay, so this video is meant for my geometry students. We're going to take a look at sections 9.1 through 9.3 and 9.6 for your quiz that's going to be on Thursday and Friday. And again, hopefully this is going to be a nice quiz for you so that you end the quarter on a great note. Alright, so we're going to look at this translation problem right here, capital T for translation. We're going to graph this translated negative 2, comma 5. Alright, so we can do most of this on the graph here. I'll do this by coordinates first, and I'll use the picture here. So if we look at this point right here, this point the coordinates are negative 1, 2, 3, 4, 5, and then 1, 2, 3. Negative 5, 3. The coordinates here, negative 2, 3. The coordinates here, we'll go in order. 1, negative 3. And the coordinates here are negative 1, 2, 3, 4, 5, 0. Now, how do we translate this negative 2, 5? Well, what this means, translate negative 2, 5, what it really means is take your x's and subtract 2, take your y's and add 5. Or, on the picture, move to the left 2 and up 5. So, we're going to do this graph, and I'm sorry for this example. I'm going to go off of the picture, but it's okay. You'll know the coordinates I'm looking for. So the coordinates here, when I take away 2, negative 5 take away 2 becomes negative 7, and 3, when I add 5, becomes 8. And again, I'm going to have trouble graphing this. Negative 7, 8, they didn't give me a big enough graph. 1, 2, 3, 4, 5, 6, 7, and then 8. 1, 2, 3, 4, 5, 6, 7. There it is, right there. Okay, so see my point above my picture. The next one, negative 2, 3. Again, let's subtract 2 from the x. That makes it negative 4. 3 add 5 becomes 8. So here we go, negative 4, 1, 2, 3, 4, and up 8. 1, 2, 3, 4, 5. So up here somewhere. And again, sorry for being above the picture. Next one, 1, negative 3. Subtract 2 becomes negative 1, and add 5 becomes positive 2 for the y. And I can graph that on this picture, negative 1, 2. There we go. And then negative 5, 0. Let's subtract 2 becomes negative 7. Let's add 5 to the y becomes 5. Negative 7, 1, 2, 3, 4, 5, 6, 7. And then up 5. 1, 2, 3, 4. And this one is right around here. So if I try to connect those as best I can, I'm going to use red. There's the new picture. And you'll see, what do? We took this picture and slid it to the left 2, 1, 2, and up 5. 1, 2, 3, 4, 5. Perfect. And there's your coordinates. Okay, so a basic translation problem. Alright, here's a composition of transformations. 2 translations. Here we go. You are visiting San Francisco. From your hotel near Union Square, you walk 4 blocks east and 4 blocks north to the Wells Fargo History Museum. So I read ahead, so I know I'm going to put the hotel down here in the center. So we go 4 blocks east and 4 blocks north. And there's the Wells Fargo Museum. So 4 east, 4 north. And then from there, you walk 5 blocks west and 3 blocks north to the Cable Car Barn Museum. So this is 5 west and 3 north. And the question is, where is the Cable Car Museum in relation to the hotel? So what is this right here? How do I get there? Okay. Well, notice you're going northwest, right? So you need to be going north and west. Well, how do we figure it out? Well, in the x direction, or side to side, you went 4 east, give that a positive 4, and you went 5 west, give that a negative 5. Overall, you went negative 1. That's one block west. So the negative 1 translates into 1 block west. And then in the y direction, we went 4 blocks north. Give that a positive because you're going up. And then 3 more blocks north. So give it another positive. 4 and 3 is 7. So you went 7 blocks north. So the Cable Car Barn Museum is 1 block west and 7 blocks north from the hotel. Composition of translations. Add them together. Okay, here's our third problem here. I'm given J, A, and G. We're going to graph triangle JAG and then reflect it using this line of reflection. Let me get a graph real fast. Okay, so I got my graph. So first I'm going to graph the coordinates, and I use red. So red, 1, 4, 1, 4, there's J, 3, 5, there's A, and 2, 1, there's G. 2, 1, I'm sorry. Not 2, 2, 2, 1. Right? So I have 1, 4, 3, 5, and 2, 1. And there is the triangle GAG. And now I'm trying to reflect it across the line y equals 2. Again, y equals 2 means all of your points have a y coordinate of 2. So it doesn't matter how far you go left or right, but you have to go up 2. Up 2. So that would be a horizontal line right there. This is a line y equals 2. So how are we going to reflect this? Well, we just need to make sure we go the same distance on the other side of this line. So if we start with J, J is 2 away from this line. 1, 2, if you count down. So go 2 this way. 1, 2. Here's J. J prime. G is 1 below the line, so we have to go 1 above the line. There's G prime. A is 1, 2, 3 above the line, so go 3 below the line. 1, 2, 3. There's A prime. And there is your reflected triangle. Okay? If I want the coordinates, list them out on the side here. So J prime, starting at the origin, is 1, 0. A prime, starting at the origin, is 1, 2, 3, 4. 1, 2, 3, negative 1. And G prime is 1, 2, 1, 2, 3. 2, 3. Okay? And there we go. The coordinates of the reflected triangle J prime, A prime, G prime. Got to make sure you know how to graph these lines. Don't forget that. Okay, problem 4 here. We're going to take the point 0, 0 and do 2 reflections across line 1 and line 2. So again, let me grab a graph. Okay. So let's plot the point 0, 0. I'll use red. So 0, 0. There's point O. And first line of reflection is x equals negative 2. So again, go to where x is negative 2. That means all the points have to go left 2. Doesn't matter how high or how low you go. So this is a vertical line. And we're going to graph across it. So I'll do that in blue. If O is 1, 2 to the right of the line, go 1, 2 to the left. And there's O prime. And the coordinates of O prime are going to be negative 4, 0. And now I want to reflect across the y-axis. And the y-axis is right here, the vertical axis. So now I'll change colors to orange. So now O prime is 1, 2, 3, 4 away from that y-axis. So we have to go 4 on the other side. 1, 2, 3, 4. Here's O double prime. And the coordinates of O double prime are 1, 2, 3, 4, 0. And that's what happens in 0, 0 after it reflects twice, those 2 lines. So notice we only used the original point once. We reflect it first to get the O prime, and then reflect that point second to get O double prime. Alright, so here we go. We're going to do our best. And again, I don't have the proper tools, so I'll try to draw it as best I can and explain. We're going to do our best to rotate this triangle 60 degrees, again, counterclockwise, because it's not mentioned, so counterclockwise, about point P. So this is counterclockwise. Alright? So again, that means we're going that way. So here's our point P. So first thing we do is we draw lines, or draw a segment, dotted line, from P through one of the points. And let's choose A. So I'll use my straight edge, right? And I'll go P to A. Okay, and now I need to use my protractor. And again, I don't have a protractor, so I'm going to do my best. But the center of the protractor is in P. One of the lines goes along this dotted line, and my protractor is below here, so that I can measure 60 degrees down. Okay, and just estimating, I apologize, I don't have the tools, but just estimating, I would say this is 90, so this is roughly 60 degrees. And I'm going to draw that dotted line. So you'd put a point out here, and then you'd connect P to that point. This is 60 degrees. So you need to create this angle. Okay? And now we estimate on this dotted line where A prime would go. A to P is that long, so we need A prime to P to be the same distance. And there we go. That's what I'll call A. So A is rotated 60 degrees counterclockwise. And now we do the same thing for D. I'll use different color. So from P through D, I'll draw a dotted line as best I can. And again, estimate a 60-degree angle. Let me go back to where's 90. There's 90. So let's see. This is about 60 degrees right here. So P to D is that long. So P to D prime has to be about the same length. Let's go right around there. D prime. And there, you'll see side AD. A prime, D prime is now turned. I'm going to use black to make my final picture. So there's one of the sides of my, that's AD right there. Looks about right. And now I will use purple. I know it's going to be really messy. I apologize. To connect P to B. So then I'll extend, I'll use my protractor to measure a 60-degree angle this way. I'll say that's roughly 60 degrees. P to B is right there. So P to B prime has to be about the same length. I'll call it right around there. There's B prime. And now I'll connect my dots. And again, my triangle looked like it changed. It got small a little bit, but that's okay. It shouldn't, but I'm not perfect. And there we go. There is a triangle ABD rotated 60 degrees counterclockwise to A prime, B prime, D prime. Okay? Make sure you practice those. Do your best. Okay? Those are probably the toughest problems. So just make sure you work through it. And again, you can't be perfect, so don't try to be. All right, here's question 6. We got 3 more to go. We're going to do a rotation of 90 degrees about the origin. And my graph, it looks like it didn't copy down the y-axis, so let me just fill that in. So that's the y-axis. So again, that should be there. It just wasn't filled in. Okay, so what I'm going to do is we're going to do the coordinates first, and then we'll graph it second just to check. Okay? So if we look down here, what's this? F, G, H, J. So F prime. I want F prime. Now, remember, when you go 90 degrees, we're going 90 degrees. We're going counterclockwise. So remember, we're going counterclockwise. That's one quadrant to the left, sort of. One quadrant this way. So first thing we do is we switch x and y. So F prime, we switch 3, 0. G prime, we switch 1, -4. X and y, that is. 1, -4. H prime, we switch. -4, 1. J prime, we switch. 2, 3. And then we ask ourselves, okay, after we switch x and y, because we are turning, what quadrant will the points end up in? Okay, well, F. F is on the y-axis. So when you go counterclockwise 90 degrees, you're going to end up on the negative x-axis, which means that you have to have a negative x-coordinate, -3, 0. So F03 becomes down here, and I'm going to use red. There's F prime. Okay. G prime now. G prime. G is going to end up in the third quadrant. Quadrant 3. And in quadrant 3, the x is negative and the y is negative. -1, -4. -1, -4. So there's where G prime turns to. So F, G now becomes F prime, G prime. There's one of the sides of my figures. H prime. H is going to end up from the fourth into the first quadrant, quadrant 1, where both are positive. So H prime is now 4. So here's the y-axis. 1, 2, 3, 4, 1. There's H prime. So you're going to notice my figure kind of twisted. And now we're looking for J prime. And J prime, starting in the first quadrant, it's going to rotate to the second quadrant. In the second quadrant, x is negative, y is positive. -2, 3. 1, 2. And there's J prime. And there's the figure. And I'm going to make that a little bit straighter. And there we go. So there is the figure rotated. And it should look about right. Okay. So there we go. So this would be your coordinates right here. So remember, it's a two-part process for a 90-degree turn. You switch x and y, and then figure out what your signs have to be. Again, rotations, toughest part. Make sure you really hone in on those and focus down. Interactive math might be a good place to go for extra problems. Okay, two more problems to go. It says the blue figure is a dilation image of the black figure. The labeled point is the center of dilation. Tell whether the dilation is an enlargement or a reduction, then find the scale factor. So we're going in this problem, and I'm going to work here. We're going black to blue. Right? The blue figure is the dilation. So the black is small, the blue is big. Well, if you're getting bigger, then you are called an enlargement. Okay. So now we have to figure out what is the scale factor. Well, the easiest way to do the scale factor is identify your point. O is your point of center of dilation. And now, are there 2 points, one that corresponds to the other figure, that you can count the distance of? Because we want to know if that distance from the center of dilation, how it changes. So you could use either of the ones on the x-axis or the y-axis. I'm going to use these two. Okay, let's call this A, and let's call this A prime. Okay, so down here I'm going to use orange. So from the distance from A to O is 2. You can count it. Then the distance from A prime to O, again, you can count it as 3. So you got bigger. If you're enlarging, that means that your n is greater than 1. So the question is, how do I arrange these in a ratio to figure out my scale factor? Well, the number has to be bigger than 1. To be bigger than 1, the top number must be bigger than the bottom number. So your scale factor here is 3/2. Make sure you always reduce the scale factor if you can. Alright, one more. Alright, here's the last problem here. It says you look at each object described under a magnifying glass. Find the actual dimension of each object, okay? So again, the image of a button is 5 times the button's actual size and has a diameter of 6 centimeters. So the idea here is you have a magnifying glass that you're looking through, and the button is underneath it. So in the magnifying glass, the button has a diameter of 6 centimeters. So when you magnify it, so as you look in the magnifying glass, the button's going to be big, and its diameter will be 6 centimeters. So the question is, if the magnifying glass does a 5 times enlargement, right, of the actual figure, what is the actual size of the button? Okay, so diameter, we use D. The new diameter, D prime, is equal to the scale factor times the old diameter, D. So this is the magnified, and this is the actual. So if I want to find the actual, I have the magnified. The magnified is 6. 6 centimeters equals your scale factor, because you're going 5 times, is 5. We want to find the actual length. We want to go back to the pre-image, if you will. So this is a division problem. Divide by 5, divide by 5. D equals 1.2. And that would be centimeters. So that would be the diameter of the button. Okay, so hopefully this helped you prepare for your quiz. This was problem 8, not number 9. I just caught that, sorry. We only did 8 problems. Hopefully this helped you prepare for your quiz, and you do really well coming in on Thursday or Friday. Alright, we'll see you then. Bye.